Welcome to This Explainer. Today, we're going to completely dismantle a decades-old scientific assumption about exactly how your brain connects ideas. For a really long time, cognitive scientists were pretty sure they had our minds completely figured out, at least when it came to how we categorize the world around us. But I want to start by having you ask yourself a question. Does your mind use a ruler? Seriously, take a second and think about it. When you consider how similar an apple is to a pear, or maybe how similar your hometown is to a city you visited on vacation last year, does your brain actually measure the distance between those two thoughts the exact same way a ruler measures physical space on a piece of paper? Well, for a massive chunk of the 20th century, psychologists believed the answer was an absolute yes.
They called this the geometric paradigm, or multidimensional scaling. And, the idea was incredibly elegant. It basically suggested that our minds map conceptual representations as exact coordinate points within a vast continuous psychological space. So, if you were to plot two ideas on this imaginary mental map, their psychological similarity was simply an inverse function of the geometric distance between them. The closer the dots on your mental map, the more similar the concepts. It sounds perfectly logical, right? But here's the catch. To maintain mathematical validity, this geometric model had to obey three fundamental rules, or axioms, of physical space. The very first mathematical rule this old model relied on was the minimality axiom. In plain English, this rule just assumes that the psychological distance between an object and itself is a constant zero. It represents the absolute minimum distance, or the maximal similarity across all entities. Basically, a thing is perfectly identical to itself, and that self-identity is a uniform, constant value no matter what the object actually is. But in 1977, a psychologist named Amos Tversky came along and delivered his first massive strike against this old model. He proved that self-similarity is absolutely not constant. When you test human recognition, our brains don't actually process everything with the same uniform mathematical perfection. In reality, our brains identify richly detailed familiar things, like familiar human faces or everyday words, much more easily and consistently than sparse, unfamiliar shapes. If recognition is a measure of similarity, and we recognize familiar things as themselves way faster than unfamiliar things, then self-similarity simply cannot be a mathematical constant. And just like that, Tversky cracked the foundation of the mental map.
So let's see how this builds against the second rule of geometry, the symmetry axiom. Now, this is the absolute cornerstone of coordinate geometry. It dictates that if you travel from point A to point B, the distance traversed must perfectly equal the distance of the return trip from point B back to point A. Meaning, if psychological similarity is just physical distance in space, then comparing idea A to idea B must be exactly the same as comparing idea B to idea A.
Let's actually test your own brain right now to see if this holds up. We'd naturally say something like the portrait resembles the person, but if we reverse it and say the person resembles the portrait, it instantly feels a bit wrong, doesn't it? Why is that? Because human mental comparisons are inherently directional. We structure our comparisons with a subject and a referent, naturally anchoring our thoughts to prototypes. You might say, my love is as deep as the ocean, because the ocean is the ultimate prototype of depth. But saying the ocean is as deep as my love totally loses its semantic coherence. This entirely breaks the rigid mathematical rule of symmetry. This was illustrated even further using a political example from Tversky's 1977 empirical trials. He asked his subjects to compare North Korea and Red China. He found that human subjects naturally rate the similarity of a less prominent variant, in this case North Korea, to a highly prominent prototype, Red China, as significantly higher than the reverse. We naturally anchor to the bigger, more salient concept. Because simple coordinate-based distance metrics are mathematically incapable of representing these asymmetric one-way relationships, Tversky argued that geometric maps just completely fail to capture how human concept comparison actually works in the real world.
But Tversky wasn't done yet. He then took direct aim at the third and definitely most rigid mathematical constraint of metric spaces, the triangle inequality. This axiom states that the direct, straight-line path between two concepts can never be longer than a detour taken through a third intermediate concept. In short, if A is close to B and B is close to C, then A and C cannot be miles apart. They have to have some baseline level of proximity. To completely dismantle this, Tversky utilized this really compelling conceptual chain. Think about it. Step 1. People generally judge Jamaica as highly similar to Cuba. Why? Because of shared geography and vibrant Caribbean culture. Step 2. People also judge Cuba as highly similar to Russia. Why? Well, especially in the context of the 20th century, they share deep political history and communist ideologies. But look at step 3. Jamaica and Russia. They share virtually no geographic, cultural, or political similarities whatsoever. There is a near total absence of psychological association. This beautifully proves that human thought is non-transitive. We evaluate similarity on a localized, feature-by-feature basis, landing the final, fatal blow to the geometric mental map.
So what's the big takeaway here? The geometric coordinate space is fundamentally flawed. We absolutely do not walk around with a static, continuous grid inside our heads where concepts just sit at fixed distances from one another. With the old metric paradigm thoroughly demolished, Tversky had to offer a revolutionary solution. And so he introduced the set-theoretic approach.
At the heart of that revolution is Tversky's feature matching model. The underlying concept here is beautifully intuitive. Tversky proposed that objects are represented in our minds as discrete collections of features. We aren't calculating distance at all. Instead, we compute similarity by formally matching features. We look at the features two things share in common, and then we literally subtract the unique distinctive features that belong to one but not the other. It's basically a dynamic accounting of what matches and what doesn't.
But here's where it gets really fascinating. The core mechanic driving this theory is the diagnosticity principle. It states that similarity is never calculated in a vacuum. It is incredibly dynamic. The mere presence of other objects in a group dictates which features we suddenly decide are important, or diagnostic. In other words, our judgment of how similar two things are completely changes based on the surrounding context of the room they're in.
To prove this, Tversky designed a classic experiment. Participants were given a target country, Austria, and asked to match it to the most similar country from a very small list of options. But he split the participants up. One group got set 1, where they had to choose between Sweden, Hungary, and Poland. The other group got set 2, choosing between Sweden, Hungary, and Norway. Notice that Poland was simply swapped out for Norway between the two sets. That's the only difference.
And the resulting shift in the data was absolutely wild. In set 1, 49% of participants chose Sweden as the most similar country to Austria. But in set 2, merely by swapping Poland for Norway, the results completely flipped. Suddenly, 60% of people chose Hungary as the most similar to Austria, and Sweden plummeted to just 14%. Swapping out one single alternative option completely rewired how the human brain judged the target.
Let's break down exactly why this matters and what you should really take away from this. It's all about context and clustering. In set 1, and keep in mind this was the 1970s, Hungary and Poland naturally clustered together as Eastern Bloc communist states. That made political alignment the highly diagnostic feature. So Austria, being Western aligned and neutral, was paired with the only other non-communist outlier, Sweden. But in set 2, adding Norway changed everything. Suddenly, Sweden and Norway formed a distinct Scandinavian cluster. This brand new context made geographic origin the most diagnostic feature. Austria wasn't Scandinavian, which isolated Sweden and Norway, forcing the brain to look for new connections, suddenly bringing the deep historic and cultural ties between Austria and Hungary right to the forefront. Similarity is highly fluid and entirely localized.
Which leaves us with a massive, lingering question for the modern age. If human similarity judgments aren't based on rigid mathematical distances, but instead rely on this incredibly dynamic, localized, ever-shifting context, how will artificial intelligence ever learn to truly think like us? If our own conceptual map reshapes itself entirely just because a new option enters the room, programming a machine to mimic this beautifully messy human quirk might just be the absolute greatest challenge cognitive science and AI face today. Definitely something fascinating to ponder. Thanks for joining me on this explainer.